Hello again and welcome to another episode of Simply Electronics. In this episode we're going to be a little bit more British specific, but if you're not British it doesn't matter, you'll still find out some interesting facts that you may not have known before. We're going to be looking at the British plug and how to wire it up, but we're also going to talk about the safety aspects that make the British plug what is considered to be one of the safest, if not the safest, domestic plug in the world. So we'll take a look at wiring this plug up. So any of you at home who don't know how to wire a plug up, hopefully you'll get an idea of how to wire a mains plug to a mains cable. Now obviously there are a lot of safety precautions because we're messing with high voltage AC cables here. If you are not experienced or you're not aware of the safety precautions for doing this, or if you're under the age of 18, make sure you do ask your parents to do this for you. So this is the British plug. It's got 3 prongs and one is longer than the other. We'll talk about why later, but first of all we're going to wire this thing up. So with these British plugs you generally will find 1 screw in the middle and then 2 screws at the bottom. The 2 screws at the bottom we can leave for now because I'm going to show you what's inside. There is usually 1 screw that holds the back plate onto this plug. So if we go ahead and unscrew this, take that screw out, save it for later when we need to put it back, and then we can just pop the top off this plug. It's just a plastic cover and this reveals what's inside. We've got a fuse here. Now the fuse is also quite an important thing to consider, but we'll get to that shortly. We then have 3 pins. So we have this pin, the top pin, and the pin that goes to the fuse. Okay, so if I pop all of these out, that's the earth pin, and you can tell it's an earth pin because there is no shielding around it like there is with the other pins. If you have a look here, there is plastic coated shielding around these other 2 pins. So the earth pin never should have any shielding around it. So that earth pin always goes on the top. So it's in the top middle of the plug. And then if you look at the plug from this direction, this would be the live pin and this would be the neutral pin. And it's actually marked on this plug, so it makes it easier for us to sort of, I don't know if it's focusing well enough, but you can see there's an L there and there's an N there, and there's this little symbol here, that means earth ground. So when we flip it over, obviously that inverts. We've got the earth at the top because it's centered top. The side that goes to the fuse is always the live side. So if I take this pin out now, if I try to take this out, you can see the whole fuse assembly comes out with it. Okay, so this is actually just the live pin. And again, we've also just got the neutral pin there on its own. Now we want to wire this to this plug so we can go ahead and plug it in. On the UK wiring system, the brown cable to me looks slightly grey on the camera, but it is brown. The brown cable is always the live cable. The yellow and green cable, that's the earth cable. We'll talk about the earth cable very shortly. Then the blue one is the neutral cable. So the main live wires are the brown and blue. The earth cable is not live unless it is making contact with a live source, and the only time an earth cable will make contact with a live source is if there is an earth ground fault, and that's what this earth cable's for, but we'll go into that later. So the 2 main live cables are the live and neutral, and just because it says neutral doesn't mean there's no power going to it. The neutral certainly does have power going to it. So the 2 main live cables are the live and neutral wires. So to wire this to a plug, so you want to make sure if your wires aren't stripped already that you just strip a little bit of the wire shielding away to reveal the copper. As you can see there, the copper is exposed. And then let's take one of these pins out. So I'll take the neutral pin out of this plug, and you should be able to see inside this plug is a little screw, and if we unscrew it, you should be able to see that it now makes space for us to put a wire through it. Okay, so this is a neutral pin, so we're going to put the neutral wire through it. So feed that in just to the point where the copper is going in, and you can just about see the copper popping through the other side, and then go ahead and screw this down nice and tightly, not too tight, but nice and securely, so that if you try now and pull the cable out of there, it's not going to happen, it's not going to move. So it's now making contact with this pin. You want to put the pin back into the plug with the neutral cable facing upwards like that. But the second thing I'm going to do is just pop this earth pin out here, and I'm going to do the same thing with the earth pin. The earth cable, the green and yellow cable, will then go this way into the brass pin, and I'm going to go ahead and screw that down nice and tightly as well. Okay, so now you should be able to see there we've got our neutral and earth pin wired up with the cables bending around in that direction. And the last but not least, we then have the live pin, which has the fuse on it. So I've taken the fuse out. What we're going to wire the live pin up to is that bit here. So we want to unscrew that, revealing the hole. So it's going to go into the plug there like that. So we want the live to come under it like that. And then we'll put the live into there and tighten it up. Okay, so we put the live cable into this part like that, and then we can go ahead and slip it back into the plug like that. So it should now look a little bit like that. So we've got all of that wired up now, but what we have to do is actually remove this little plastic retainer. You can see under the cable here there's a plastic retainer, and what this does is, of course, it retains the cable and prevents it from coming out when it's pulled. So it makes it safer in that respect. So I've gone ahead and taken the plastic retainer out, and then what you want to do is make sure that you lay the cable just into the little recess there so that it stays in the middle of the plug like that, and make sure that none of these cables are too tight. Okay, make sure they're all out of the way, make sure they all fit in properly, and then you can go ahead and hold your plastic retainer over there, screw them down a little bit. Okay, so it's still loose for the moment. Make any last adjustments to your cable if you need to. Okay, so the plastic retainer is now in, and it should be tight to the point that when you put some pressure on this cable, try to pull it, nothing should move. Okay, but it shouldn't be too tight as to actually put too much pressure onto the cable itself, because you don't want anything splitting, especially live cables. So it's now well retained. We've got all of the wires wired up to our pins, and the last thing to think about now is the fuse that we're going to put in. Now you can see here I've got a 13 amp fuse. 13 amps is generally the maximum current that you can draw from any UK domestic socket. 13 amps and 240 volts, you'll generally find that's about 3.1 kilowatts. So every individual socket can draw a maximum of 3.1 kilowatts. But it also depends on the maximum current rating of your ring mains that comes into the house. And I'm choosing a 13 amp fuse because it's going to an extension cord anyway, an extension reel. I really want the highest rated fuse within this plug. But if you don't know what current rating your fuse should actually be, look at the device that you are wiring the cable up to. For example, if I'm wiring up a small lamp that only requires, say, 20 to 40 watts, there's not much current being drawn at all there, because the current that that particular lamp is going to draw is quite minimal. It's less than an amp. And generally the smallest fuse I think you can get, I might be wrong, the smallest fuse is 3 amp. So you want to be choosing a 3 amp fuse for that particular application. But anything high powered like washing machines or heaters, you're probably looking at a higher amperage fuse there, say maybe 10 or 13 amps. We're all wired up there, and we'll put the cover back on there. That's important. You don't want any live wires being exposed when this thing's actually plugged in. Make sure everything's tight, and we're all good to go now. So I can plug this in, and that's it. So let's talk about the British plug and why it's actually considered to be the safest plug, or one of the safest plugs in the world. So we've got 3 pins, and in many places there are only 2 pins, generally live and neutral. I know some countries and some places have the 3-pin system, and some of them have the 2-pin. The 2-pin will just be live and neutral. So the main reasons why the British plug is so safe: number 1, we have the earth pin. The earth pin is there just in case there is a short. And what I mean is, by a short, let's take this power supply for example. These are power terminals on here, there's output terminals, and then there's a live, neutral and earth input. So if I go ahead and I clip this multimeter to the earth pin on this power supply, and then I check continuity between the earth pin here and this metal case. But if it's earth, it makes it safer. You can see that there is continuity between that earth pin and that case. That means that if there is a fault where the live mains potential has shorted and touched this case, the first thing that should happen very, very quickly is that the main fuse breakers should just automatically trip, because it's sensed and detected that there is a fault where the live potential has managed to flow through to ground. The second thing is, if there is a live cable touching this metal case, then because the case is more grounded than yourself, the electrons should take the better grounded path, which means you're much more likely to be safer if you touched this case than if it wasn't earthed at all. So the electrons will more likely flow through to earth than through you and to ground, because you are more resistant than the direct link between this case and earth ground. Let's go back and look at the other reasons why the British plug is one of the safest. Because of its design for the live and neutral pins, there is a plastic coating on both of the pins, because these are both at live mains potential. You can see that this plug is actually partially out and exposed, but there is actually no metal exposed on the live and neutral side of the plug. If I turn it over, you can see it's just the plastic, and that means it's absolutely impossible for even a child to get their fingers under there and actually be able to touch the live pins, because the plastic is covering it. And once it's out far enough that the metal is actually exposed on the pins, then there is actually no live voltage on there anyway. The final reason is because of this system inside. And you can see inside the plug there is a shutter system. And this means that in the UK, you physically cannot put your fingers inside and touch the live connections. And this is the reason why the earth pin is longer than the rest of the pins. The earth pin has to go into the top hole first because it has a shutter mechanism. If I press the shutter in there, you might be able to see that then exposes the internal contacts inside there. And that's what the length of the earth pin is for. It's for pressing that shutter down for the other live and neutral pins to then go in and make contact. So as you can see, the earth pin goes in first, pushes the shutter open, and therefore lets the other live and neutral pins go in. Take it out and the shutters are already closed. You cannot touch it. You really, really do have to absolutely try to break the rules in order to make the British plug and the British plug system unsafe. And that's why the British plug design is generally considered one of the best, if not the best, and safest designs in the world.